I want to refresh your memories about how we dealt with the vehicles. So vehicles, keep in mind, that's the same as animals. If you claim that you're a free thinker. So animals. Motor means muscle mass, and fuel means food in the stomach or in that pouch under the beak of the bird. What's the English word for that? Every bird accumulates grains under the beak in a sack from which over time the grains are traveling into the bird's stomach. There's a name for that, which I will look it up if you guys don't help. Even better, get to know a chicken, okay? Not the one from the grocery store. Just get to know the world around, meaning outside the city. And so the vehicle has a body, and the way we looked at it, speed, the mass of this mover was assumed to be dominated by two organs, the fuel load and the motor size. That was the so-called model that we juggled. I forget how many lectures ago, maybe 3 lectures ago. So the first panel is a reminder of what we have done. So this vehicle travels from here to a life travel and lifetime. We've done this. And we wrote a few statements here which are relevant next, as you'll see. And they have to do with the fact that the fuel, once burned, this is the heating value, produces a heat input called the capital Q, a number of joules. You've heard of Joule, have you? James Prescott Joule. What university did he attend? This is England, around 1840, 1850. What university? There are not many universities in England at the time. Which one? This guy.
Oxford.
Somebody?
Either Oxford or Cambridge.
Oh, come on, Ilana. You know I'm a joker. I'm a trickster. He did not go to school. He was educated. He was educated by his father, who was a successful brewer, and who hired homeschooling for him. And this boy never left the brewery. The brewery had a very extensive, obviously, spent time in a brewery or in the wine house of a vineyard. Anyway, extensive shop, a machine shop. And Joule was a gifted instrument maker. And he made the instruments and the experiments to test several of the theories of his close friend, William Thomson, who later became Lord Kelvin. And the world knows about Joule because of the symbiosis of himself with William Thomson. Where was he, William Thomson? Where is he from? He became Lord Kelvin. Kelvin is a river in Glasgow. Yeah, that's where he was from, okay? He was not English. You've heard of Glasgow? It's in Scotland, okay? You got to connect the dots in life. Anyway, so this Q, through the motor of the vehicle, creates work. The work is the efficiency times the heat input. The efficiency, thanks to the predicted phenomenon of economies of scale is greater when the motor is bigger, and we accounted for that with a formula. And by the way, this formula is predictable, but I did not do that here in this course. Motor mass to an exponent that's of order 1 but less than 1. And all these ingredients, there is also, of course, the friction force here, which is mu, and then the weight, which is mg. And so the dissipated work is the force, mu mg, times the travel, capital L. All those things were combined in a previous lecture to discover that the product ML, which I called movement. By the way, this ML, I did not say that the time is movement, all right, but I've already assumed that this capital M is fixed. Varying is the relative size of fuel load versus motor. Which one should be bigger in the constitution or in the making of this drawing? That is the question. So there's a 1 degree of freedom when you have two bodies, and that degree of freedom is the relative size of those two parts. Anyway, combining these things, we concluded that the product, so-called movement, which by the way is proportional to travel, because m is fixed. This one is fixed. This other one is to be maximized according to the Constructal law, because if the object has freedom to change, it will change in direction of greater and greater access. Anyway, that group varies as motor mass to power alpha times fuel load, and the right-hand side can be maximized subject to this constraint. So subject to, I call it equation 1. And the results that you already have in your notes somewhere are conclusive in the sense that everything, the organs, are scaling with capital M. So the motor mass relative to the total size should be alpha over 1 plus alpha. Remember, alpha is close to 1 but smaller, for example, 3/4, that kind of a number. And then fuel load relative to M is 1 over 1 plus alpha. And then you can divide these two to find that motor mass scales with the fuel mass, meaning more muscular birds will be flying from Alaska to New Zealand based on larger quantities of fat stored on their body for the travel. And then the bottom line is that this product maximized should vary as m to power 1 plus alpha. If you divide through capital M, you discover, you're not surprised, that yes, the bigger should travel farther. After all this freedom in how the motor size is balanced more and more wisely relative to the fuel size and vice versa. Now, what is new? more like, I have not published this. What is new is a new exam problem one day. Is what if we try our luck and say that the model of this vehicle is more complicated? It has three parts, clearly. It's not only the fuel and the motor, but also the dead weight, meaning the chassis. And speaking of dead, the occupants of hey, look, they're not doing anything when they're being driven around, okay? They're not helping. They're not pushing the cart. So three-body model. So meaning what if? Well, capital M in this new model is MF plus M motor plus M structure. That's the chassis, the seats, the roof of the automobile, and the occupants, and the suitcases, and all the other things. Okay, so that's what we have here. In principle, 2 degrees of freedom, not 1. But because life is short, just for your benefit, I decided to assume one of those degrees of freedom away, and to, meaning to assume and to confess that as a first approximation, the size of the structure is a fraction of the total size. Meaning big vehicles weigh more when empty. Meaning when they have no fuel and no motor. This is in fact true of the shipyard next to which I grew up. They make cargo ships for the ocean, and these ships are the size of these ships is indicated by as a number of tons of dead weight, meaning the shell. The shell, and only the shell, is what indicates the size of the vessel on the way to selling it. And so the tons of dead weight is equal to gamma, capital M, of what would be the real mover, okay? And this is the only move, pardon the pun, the only move that's new in this new version of the analysis. In other words, what I put on the left-hand side gets repeated. Meaning everything. And if you want to practice your love affair with algebra, do that. By the way, since Hamad, my PhD student from Saudi Arabia, is not here, so who invented algebra? Algebra. You don't know? You never heard of this? Come on, there are books written about how the Arabs brought mathematics to Europe and all that. Yeah, forget it. No, the inventor of algebra was a Persian. And he lived in what today is called Uzbekistan. But back then, because at this time, which is at the end of the first millennium, the territories north of what today is called Iran were actually speaking Persian, and they had been Islamicized by the Persians. First, the Persians fell under the Arabs, but the Persians had the culture of moving on wheels, not on animals, and And so I forgot I cannot pronounce his name. His name, this Persian, his name is the one that led to the word algorithm. Algorithm comes from the name of the Persian who first wrote the book that's called Algebra. All right, so speaking of your love with algebra, you repeat what's here, and you get, instead of these simple things, you get the same conclusion, that the motor mass relative to the total mass is 1 minus gamma alpha 1 plus alpha, and then the fuel mass relative to the total mass is 1 minus gamma over 1 plus alpha. And what really matters in the constructal sense, meaning life travel in this case, is that the maximized travel goes as once again as m to power alpha, which was the same conclusion as here. So worth retaining is this more complicated model, the same conclusion. If you have time to spend or to waste, make the model even more complicated and see whether the conclusion is robust. Usually, the conclusion is robust, but I have not tried it. You have your own time supply, and therefore use it. What about the lifetime of this object moving to the right? Well, lifetime is the life travel divided by the speed of the vehicle. For the travel, we have m to alpha. For the speed, if you remember my more than one lecture on animal locomotion, the speed tends to be greater when the body is bigger. All the animals, but also the vehicles as well, land vehicles, air vehicles, yes, maritime, the same thing, just like the birds, runners, and the fish. They're faster if you go vertically from water to air, but when it comes to size, the bigger are faster. And that dependence on m is like m to 1/6, meaning that the life time of this animal vehicle should vary as m to alpha minus 1/6. And as I said, alpha is of order 1 but smaller than 1. 1/6 is basically not of order 1, it is of order 0.1. And that means that this exponent, if you plug some values for alpha, is comparable with, say, 1/2 or 2/3, and so on. And these are conclusions that emerge once again on the back of another envelope, which I just sketched here. And it is only after this exercise that a man who imagines, in this case Adrian, goes to the books of zoology, which are full of data on the lifetime, in this case, of animals. And there are plots of lifetime versus body size, and these dots line up according to this kind of power law with this kind of exponent. No explanation for the exponent, when in fact the exponent is the question, because everybody knows that the bigger live longer, you know. Get it? But very few people question what everybody knows. And that is the advantage that you have for having taken this course. At this point, I am erasing the blackboard. The first speaker, you'll arrange. Do you show any slides when you talk? Fine. Then where is my my helper? Please stop recording. I need my. Okay. I'm gonna erase the blackboard. And then.